So today I will try to quickly show, it's my personal project about trying to use Flamegraphs for plotting MySQL plan, right? MySQL, the explain queries, right? So just to introduce myself, a few of you already know me. I'm this guy on the left. I've been working at Percona for 8 years already. I wrote a book about learning MySQL, and also I'm one of the organizers of the MySQL community in Brazil. So we're doing an event in the end of the year in September. If you guys want to join us, I will be happy to receive you in Brazil. Why I'm here, the topics of the agenda today. So I will try to explain briefly what is a flame graph, why they are useful on their most traditional form, the use case, and how I accomplished plotting the MySQL stages using the new features that MySQL 8.4 introduced. And the project, I call it My Flames, and I will try to show you some examples. And also, given I was testing with AI, I was also able to produce bar graphs, which a few people might find it more intuitive to interpret as well. So, what is a flame graph? The idea is not mine, neither the one using SQL, using flame graphs for SQL queries, or neither the original idea. It came from Gregg. It's like famous guy in the ecosystem, right? And it is a technique to visualize performance data in a hierarchical way, right? It was created by Gregg. Probably his book about system performance is very famous. I think most of us should have in our shelf. And it's basically like plots in a XY graph how to interpret the data. It will show on horizontal where time is spent and the depth of the code path on the y-axis. So I will show you here. The idea is to quickly identify, just by looking at it, where the CPU is spending time, or in our case, where the SQL query is spending time. This is a traditional flame graph that I extracted from Idlebox, right? So this is the MySQL D process, right? So this it's a perf, it's collecting samples, and as we can see here, the MySQL D is the whole process. It's the one sitting in the bottom, and then we have the columns representing each function. In this case, it's a replica, and we can see a syscall. It's basically reading events. It's the I/O thread that is working, and we can see the depth here. So every time you click on it, the bar goes expanding and shows you the code path. This is the very basic, right? And why they are useful? So I did one test using, again, traditional flame graphs, where I was doing a full scan, a select star without filtering. And we can see here my MySQL process, and basically a single thread here using basically the entire CPU slot here. And we can see that this large bar, it's executing a MySQL command, doing a select, right? And it's reading row after row, right? And more here we can see syscalls, because the buffer is requesting data from the disk, so you will see the invoking syscalls, right? Pretty basic, I think, basic in the sense like a lot of people already discussed it. For those who already know the traditional, this is the classic case of flame graphs. So they are useful for a few things. Like most of the time, at least at Percona, we as engineers, when we have a CPU burning, we ask to collect some OS metrics, but also in some cases we ask for perf data to identify these hotspots, right? So we can identify from the code level which is actually burning, because sometimes it can be not only the query, but maybe MVCC, adaptive hash index, or something like this, and we can find this through perf. And we can do performance tuning at application as well, right? So if you identify where your application is spending the most time on CPU on that particular function, you can work on that, trying to optimize or understand, right? Say, we can also use through kernel and OS analysis. There is also Flamegraph for we call off CPU, which is like on the contrary here. We have what I would call the off CPU analysis. Is this blank space is being filled by syscal's operating system. So this is what the off would do. It would be creating a like this, but inverted, right? So these two graphs would merge and give you the full picture. That's what off CPU Flamegraph works for, right? That's what I mentioned. So you can identify. It works also as well because many people worked on it. So it works with BCC tools. So you can also collect metrics from different perspectives from the operating system, right? And again, like I think Mark Callaghan, he also uses it. He already identified some regressions. One of them, if I recall from the top of my head, it was one way that MySQL was being compiled, and he found out by doing Flamegraphs. And again, like the classic way is to analyze code paths, right? So now that we start diving on what we want and talk about SQL queries, how this became possible in MySQL, right? First, what we had until MySQL 8.4, what was the classic way to analyze queries? We had the traditional, you do explain, then you get that idea of how the query works, an estimation. We have a different format with JSON, so you would explain format would give you extra metrics in JSON format. MySQL 8.0 introduced the format GO3, where you had like each line in the with indentation going deep, right? And they also provided us with explain analyze. What explain analyze do different from the others? It will run the query. It will run the query and give you, instead of estimated data for like expected index to run, expected amount of time, it will give you the actual time, which is really good. But the explain was not in JSON format, and this came solved with 8.4. Because before, if you try to run, it will tell you like, I cannot plot in JSON. And the beauty of JSON format, you can check in the blog post, but it's this new setting where you can use the version 2 of the explain format JSON. So before I was having the error, but now with the new explain format, you can get in a JSON format the actual number of rows executed in every stage. Remember, like we had on estimation, and now we have the real time. So that allows us to have a precise idea of what is happening, not only based on statistics, right? So that is really good. And why JSON? Because we are in the AI era, whether we want or not. And parsing JSON data is really way easier for the machine than like having non-structured data that the other explains provided to us. And with that, I decided to use, to get some inspiration by Tanel Poder. I'm not sure if you guys work with Oracle. This is one of the gurus from Oracle. And again, this idea, this whole concept was not mine. I just brought to MySQL. But this is his idea and what I try to bring to MySQL, right? So you can plot your queries in the same way as we do for traditional. So the longer blocks, the queries that are consuming the most time, right? We have on the horizontal, this is a SQL statement, right? So it will fill up 100%, but we can see the stages going up, right? So you read bottom up, so you can see here, it's going deeper. The hash join is where it's spending the less time, right, on that side. So the bigger blocks are beneath, it follows way up in the same way, right? So with that, I try to bring this to MySQL. I named it MyFlames. I used the AI to develop. I didn't have any security concerns because you grab the explain, you paste it, and you code locally on your machine. So like it's really easy to do this with AI. I use Cursor for that, and also Gemini. The Cursor, you can open the GitHub. I forked the project from Gregg, and use Cursor to do that. It follows the same idea, right? So I was wondering last night, like, is my presentation going to be useful? Because I use the AI to interpret the data. Why not use AI directly, right? It would make a lot of sense. And it is true, most of the queries nowadays you can optimize with AI. You just throw the data there. You can put the explain, the create tables, and he will give you an accurate answer. But there are certain cases that I still find valid for you to see, or even to provide more context to the AI. So that's what I will try to show here. This is a demo. So this is the explain analyze. It's a simple query. Select with two predicates, like doing an equality match. Let me see if I can show quickly here. So that query, at first, I created without indexes. It's the employees database from GitHub. We can see here the query is doing a full scan. It's doing the filter and table scan, right? So it is spending a lot of time doing the this. I also try to put, like in the text when you put the mouse over it, the extra information that you can extract from the JSON. So you have the estimation and actually like how much time it took, to find the first row and the last row. This is all in the JSON, right? And in the same way, like you can go click the same way it works with the Flamegraph, okay? This would be easy. We can ask AI, okay, optimize for me. But let's say I tried to do it myself and I created two indexes. Remember the query had a predicate on first name and last name. So the query is running better, but shows for me here, like I'm still spending a lot of time on intersection. So remember MySQL has optimizer switch feature that allows you to merge two indexes to provide you, or try to provide you a faster response, right? Maybe your AI could have give you that, you know? And what happens is like, now you have two index range scans happening, right? On the index first is the first name and the last name, right? So, okay, my query is good, my AI provided me something, but maybe I can go deeper. So I can create a covered index, and now my time drops, and I can see that now I have just an index lookup with a single stage going way faster. So at the same time, AI can help. I think that for people that still like or more complex queries, it will help you understand better the things. I would like to show another query, but this time I didn't optimize it. So we can see it's a bit more complex. So there is a join on it and having a group by operation, right? So where is my mouse? It's this one. So
Maybe could you add some
zoom?
Yes, yeah.
So here, like, then we can realize like things are a bit different. And for example, limit is taking a large portion of our query execution. And also when we see the aggregate here, it is using a temp table aggregation. So it gives you some idea and what it can do. Like since it's using a temporary table, maybe you can increase the size of your temp table and do better in memory instead of going to the disk. So you can try to reduce this, or you can try to move the aggregate out of it. You do like a subquery or something like that. So at least the idea is to give you ways to understand how it works. So it is doing from basically like the inner join is almost optimized because it's doing a single row lookup on one side of the join, while on the other it's a covered index. Maybe what you could change here is how instead of doing nested loop, doing a BNL, not a BNL, the other algorithm I forgot. Yeah, that you can change on the optimizer switch as well. So those are things that I have been testing with AI, and they are not providing yet this kind of deep down information. Like it tries, the optimization will try to cover most of the database. Maybe Oracle or Percona or someone else can train an AI agent focused on MySQL, which will be able to like try to suggest optimizer things or not. But at least now, it will give you some idea how to work better, like for more complex cases. Just talk a bit, just like more about the project. It supports the same commands as the classical Flamegraphs, so you can increase the width, you can make inverted or add titles, everything that's on the traditional Flamegraphs, it supports the same. I didn't push the last updates in GitHub, but I put it there, like it's free to use. I like to show it because sometimes for especially customers or when you're trying to explain for people not familiar with it, it's easy to show this instead of a huge JSON. So that was the main idea, right? And as a bonus, again, because AI is quite flexible and I was trying to collect some feedback. People that were not familiar with Flamegraphs thought it was a bit hard to understand. So there, I also put a bar graph. So like I think it's easier for people not familiar with it because it's top down, right? You get the one spending the most time and goes top down spending the less time. Like it's fully interactive. Again, if you want to send to someone and do a performance analysis in terms of stage, it is easier for you to interpret the data from top down. Okay, my aggregate, as I was talking before, it is where it is spending the most time. So maybe I can increase the memory, so I can try to do in memory, or I can do something else to reduce this stage. You can see that limit is sorting limits are like extremely fast operations. So increasing sort buffer size or eliminating this stage, it won't change a lot the behavior of my query. So this is another option as well, right?
Excuse me. In the previous slide, maybe it's not the same SQL, but the limit was the one at the bottom in a flame graph, and that's the one that was taking the most time. So are we talking about this? Because here it takes very little as opposed to...
It is the same, but that's how it works. How to explain, like, the way you see the flame graph, like in this case for the queries, because the limit is the last stage to finish the query. So you're going to start from the top here, where it is spending the time. So it works a bit different, and that's why I created the bar graph. Because this is it is ordered by the stages here. So you see limit, sort, filter, it's how it was processed in MySQL. So it's, in that case, in the bar graph here, it is organized by time spent. Rather than here in these ones, it's always by the stages.
Correct, that wasn't the idea that looking at the flame graph based on the length, that's, you identify the one taking the most time. So if I would rephrase the question, if you look at the bar, it's very easy. So what's the equivalent of the bar in the flame graph?
Yes. So I would look, because these are, let me just make it a bit smaller. Because here, these two, they are using like, they're picking up the entire rectangle, right? The ones that are spending time are here. Because they are smaller here, like the aggregate. And it is where, like, if you pick here, it's where it's spending, because you need to look at the difference of the time, right? You have here in the bottom, 1022, 22, but you see, you need to analyze the difference between one and the other. So this stage from table scan to filter are fast. But now, when you get the time here from 320 to these stages where you see the big gap, right?
I don't know exactly like on this one, but the flame graph itself, like the things on the bottom, they are like the entering function.
Yeah.
So these will like sequentially or like nested be calling other functions, and those functions on top are the ones that are normally taking more time, because the more on top and wider it is, it's where your hotspot is.
Okay.
In a way, you can say that in this case, it is important, the empty space is important.
Yeah.
The bigger the empty space above the bar, the more overhead the step introduces.
And because if you think here, like the limit is the last step, so there's no way it will take most of the time.
That's intuitive. Okay.
Yeah, and I think this is why, for example, the bar graph also helps, because like then you can see ordered by time, not by stages, by the code path, the SQL path, I would say. So you can have a different view from here as well.
And it's a little bit more user-friendly in that sense. Like people would interpret it that way better than looking at flame graph. Flame graph, it's like you're engineer, you know what flame graph is, but for a user, like, okay, the bar graph makes sense.
Nando?
Yeah, I like the bar graph more, but maybe we don't need to order it by time because it's already very clear, and keep it on the stages so we have the sequential order, the same sequential order from the flame graph, but with the time distribution of the bar graph.
Yeah, could be, but then like you would kind of break the flame graph, because then you are not doing the stage order anymore.
Yeah.
So
Maybe there could be a sort button where you can
yeah, because I try to put like if you order here the flame graph by time, then like you have different sizes, you know, like so it doesn't, it doesn't look good, and it's even harder to interpret, right?
Yeah, that's
But I think that's the thing, the combination of both to give you a better idea. Yes?
I like Flamegraph. If you want to invert it, it's called MySQL if you want. But the question is, are you going to add it to PMM?
That's to then like it's really a small script could be like
but a nice feature request. I like.
yeah could be. We are working on Mongo. There was this discussion about MongoDB interpreting some graphs, but yeah, I think so. There was a discussion, like Marcos, one of our guys, he was always pushing for the classic frame graph. So you were seeing some problem, you would press a button, it will collect and give you. So.
Second question, do you aware about Flame Scope?
No.
That's from the same Gregg story. It's for Linux analyzing things. In fact, this PGP, in fact, is you are painting over the time the load on the server, and then you visualizing the multi-threaded story for all the multi-parallelization query, most hot spot for the last minute, days, whatever. And you can precisely pop up the problematic moment in millisecond precision and analyze it that query only. Because then the query might affect each other, and the single query which is on statistic of PMM is on top. It's not your root problem when your disk is overloaded, things like that. So consider also to add Flame Scope.
That's nice. I think my initial plan was working with MySQL handlers, right? So you could have idea of like what is going to the storage, if it's doing a next look on primary key lookup, or if it's doing full scan. But the handlers, they are not very structured, and I was suffering a bit to do it. Maybe something that we can mix both MySQL stage with the handlers to give you a more, not sure if it's exactly the same, but then you can have a more global view because you see more resources being used from MySQL as well. So yeah, it's cool.
Is there a way to integrate these local logs to capture, for example, a window of time, like 5 minutes? I'm gonna observe my database for 5 minutes, collect all the queries there, and then use the application to go there, grab the JSON format, because it doesn't do that by default in the local logs.
Yep.
And then convert to.
Yeah, but the thing is, this is for a per query. When you analyze a 5 minutes, like you are analyzing a lot of queries, and maybe for this you would need to analyze handlers or some more global metrics from show global stats, so you can have a flame graph more in a classic approach, but from MySQL metrics instead of CPU. You would see, for example, OS metrics written or whatever in this way.
Right.
Okay, just to finalize, I was going if you have questions. I mentioned the bar graph. One last advice from Percona. Percona Live, it is coming. Marco Tusa is our supermodel Italian guy here. Be there to watch him. And I want to say thank you. If you guys want to know more or like have any suggestions, again, this is my hobby, like trying to do something. I'm not a programmer. I don't want to disrespect the professionals here. It's my hobby. Thank you, guys.